I'm Mikkel.
Okay, good. He got it.
So, my talk is called Lumo in the Sky, and the reason is that we should put some ClojureScript in Lambda in this talk, so hopefully the live coding gods are with me. So let's try that. There are many ways of getting ClojureScript in the cloud, right? But let's try it live. So let's create a function. And if my mouse works, let's give it a name. Hello from ClojureScript. Yeah. Reason for yeah is that I already did this name a few times. So what runtime do we use? We could use Node, but I think we'll just say provide your own bootstrap. So what's a bootstrap? That's the thing that runs the code. So luckily I've already done the thing that runs the code. It's called a runtime. It uses Lumo to just execute ClojureScript directly. So here we have the function. We need to specify the runtime to say how the code is executed. So we provide an ARN, which I have here from this project that is called AWS Lumo CLJS runtime. And we add that. It should be quick. So let's go back to our code. And here we actually have an editor that works with ClojureScript. That's pretty cool, thanks to Amazon. So we need to make a namespace. We could call the folder hello, and we could make a file called core.cljs to be enormously inventive. So let's edit this like this. We say ns hello.core. And then we need to define a function. We could call it handler. And then we need to do some coding. And that's, okay, parinfer hasn't come to Amazon yet. But we can say print line. Hello from CLJS. And then why don't we return some Clojure data? World, maybe like this. We need to match the parentheses. Whoops, like that, and like that. Okay, now we just need to specify our handler. That's hello.core/handler. And then we save it. Does it syntax pass for you guys? Yeah? Hopefully it does. So Amazon is doing its magic. Now we want to test it. We need to have some test data. I'm not using it for anything, so whatever. But we're not using the input. So now we have a function and we have some test data. Let's see if it works. Cross our fingers. Yay! It did. So we have hello world as an output, and down here we have hello from ClojureScript. So it worked! Yay! I'm as amazed as you are. So this project I made, I was inspired by Antonio, who made Lumo. He did a runtime for Camel, and I used Lumo for doing it for ClojureScript, together with a guy called Ricardo, I think. So yeah, the runtime is available for anyone using this ARN, and it supports Clojure libraries and NPM libraries as well. So it should be production usable. Performance-wise, it might not perform as good as so much any other, but it has this teaching essence. It's easy to get going compared to compiling ClojureScript. So yeah, that's it. Thanks.
Please give it up for Daniel.
A couple of days ago, Theodore, is Theodore here maybe? Oh yeah, so Theodore, he told me something. Oh yeah, so Theodore told me something about our core principles that are driving us as a community. And Theodore told me warmth, like a new word that I was learning from him. And then it made sense. And you may not realize, but for me, the last few days were very cold outside, and it was really hard on my body. And maybe also because of that, what Theodore said to me was really making sense at that moment. And I found so much warmth in this, in you people in the last few days, and I'm grateful for that, and that affected me, really. What I wish to show now is a little thing we have been doing. So what we have here is the website of ClojureD, a group doing open source in the last year that I've been part of. And yeah, it needs some redesign. We kept it gray for now. And one thing that we have here is trying to actually map the landscape of libraries. And there is a list of libraries which are related to this field of data science in Clojure. And not all of that is related to Clojure itself, but mainly to friends of us. And we are interested in all of that. And one chapter that you have here is the so-called literate programming and data visualization. Does any of you know any of the libraries mentioned here? Yeah, right. So it's known to most of you, and I guess so. The idea, these two things are kind of coupled, like being able to visualize and being able to tell a story in what they call a notebook. So there are many of these, as you see, and maybe only one of them might not be known to you, and that is Notespace, that we've been working on. And so let us just briefly see what it is. So it's a library. It's joint coding with Tomasz Sulej, who couldn't arrive in the last moment and asked to say hello to you. And also it is very much affected by long conversations with Nick Stairs, who is also here. And let us see a small example. And so the idea is, yeah, to be able to document and test and explore data all in the same place. We render this kind of thing where we have code with input and output, yeah, and we can render in different ways, and we can render as hiccup and as markdown, as you may expect, and there is some visual stuff, and we can do tests, and we have some summary of the tests. So we have been using it for testing and documentation in mainly in clojureD, which is a library we are working on. And the idea is to be able to do that work of data exploration and documentation and testing and visual stuff, do it without leaving your Notespace, your namespace, I mean your editor, your beloved editor that you wouldn't like to exit ever. And so let us see. So the code behind the scenes is plain Clojure code, nothing more, and it looks like this, yeah? So it's full of notes, right? And so that's why it's called Notespace, because it is a notebook in your namespace. It's full of notes. And so let us have some short experience of what it feels like to work with it. Sorry that I cannot see. Yeah, so I evaluate the namespace for the first time, and it will load in a moment. Too many dependencies, sorry. Yeah, and for now it is Emacs, but yeah. So we got this browser next to our beloved editor, and we can ask Notespace to render, and then it renders. Yeah. So, and the thing that sorry for this. Oh yeah. So what we did is just make a small update in one of the nodes, and we could re-render just the part that has changed. So it is kind of a live reload, very basic live reload experience, ending just in a moment, yeah? And yeah, it's okay, yeah? And so that is what it is, and we will keep experimenting with that. Everything breaks easily, everything is experimental. And let us just for a moment go back and go back to where we started, which is this list of libraries that we've seen. So why so many? Is it the thing they call the curse of Lisp? Is it a problem that we have so many? And why another one? So I think we have a problem. We have a problem because our user experience is not good enough yet. And the idea is to keep experimenting, but then keep talking and compose with the others. So the goal is not to be yet another one, but to be able to compose. And that is why, and that is the bottom line. Thank you, and sorry.
It's okay.
So the bottom line is keep experimenting all the time. Do those lightweight experiments, and then keep talking all the time. Thank you.
Welcome, Daniel.
Hi everyone, I'm Daniel, and that's me on the photo. It's actually a slide from my talk at EuroClojure back in 2016 in Bratislava that's been taken out of context by someone and published on Facebook, and then it went on 9gag and got republished and liked a crazy number of times. And so this is a single most popular talk from EuroClojure on YouTube these days. History likes to repeat itself, and back in the slides that are not here, I talked about something I did called Skyscraper, and I just released a new version of it, and I wanted to talk to you about it. So what is Skyscraper? It's a library, actually it's a framework for structural scraping of whole websites. Now, what does that mean? Let us consider a fictitious website that is called Conference News and has some news about conferences that are going on. Imagine we start with just the URL. So we have a map here that contains the URL key, that contains the initial URL, and something called processor, which tells Skyscraper to process these kind of pages in a certain way. Now, when this page is downloaded and parsed and picked up, it may contain a series of articles, each of which has a title, a URL of its own, an article ID, which is a kind of a ending part of the URL, and the next processor to process with. And when you do go to all these URLs again and do the same kind of thing, you might end up with another series of maps, which I call context, by the way. And each of these maps contains initial data, additional data about the article itself, including its body. Now, the thing that you need to do is to tell Skyscraper about how to actually get into the page and parse it. And this is an example. It's a technical code. I don't expect you to understand all of it at once, but the gist of it is you take the parsed website, look for links in it, and construct a map with this URL, title URL and stuff based on all these links. And yeah, so this is how we run it, and you get this thing back. So this is Skyscraper. This is how it worked from its initial days. The new version that got released 2 weeks ago or so is a rewrite from scratch. It's based on core-async now. So it's faster, it's asynchronous, it's much more robust. It's much more battle-tested, it has better documentation. And the thing I'm particularly proud of it is the database integration that I want to tell you about. The new in this version of Skyscraper is you can put these little things here called Skyscraper DB columns and Skyscraper DB key columns. It's just a vector of fields that you have in your maps. Now, when you go and rerun Skyscraper and pass it the DB file argument, what it does, it out of the blue, out of nowhere, it creates a SQLite database that you can then connect to with a SQLite client and look at the schema, and it has created a table automatically. Each of tables has an ID and parents, and the tables are interconnected in the way you expect, so you can select it, do the joins, whatever you please. And that's all I have, and happy scraping, and thank you.
So Arne's going to talk about Regal, and I'm sure he's... what?
Regal.
Regal.
It's an English word.
I don't know.
It means like a royal.
It means like a royal.
Yeah, something that's
when you say it in German, like Riegel, it means
yeah,
chocolate bar.
Well, yeah, well, Regal is like a something else, right?
Yeah, but the way you say it, like if you would write that out, like it would mean chocolate bar. Okay.
Do I have visual?
Doesn't look like you have. Now you have.
Okay. All right.
You good?
I am good.
Okay, then give it up for Arne.
Actually, I'm gonna time. Yep. Keep going. Okay, so yeah, I want to talk about Lambda Island Regal, which is a new library, because everybody loves regular expressions, right? Who loves regular expressions? Whoa, regular expressions are awesome! So this is a regular, or two regular expressions I wrote after staring a day or two at a bunch of RFCs, and I never want to touch these again. And because I never want to commit such atrocities again, I created Regal, which is sort of in pre-release on GitHub. It's very fresh. So what can you do with Regal? Well, Regal lets you write Regal expressions, which are these GitHub hiccup-like things. And then what can you do with those? Well, there's a regex function, which takes a Regal expression, turns it into an actual regex. Okay, so that's nice. What else can you do with it? Well, it also generates with test check generators. So you can take that same expression, and now you get a generator which generates conforming values, and you can do property-based testing. Okay, that's nice. What else can you do with it? Well, it integrates with spec. So here I'm using this Regal spec function to take Regal expressions and turn them into specs. And the nice thing is, if you look at the second one, it actually references the first one. So you can use these now to validate, to generate values, and you can sort of incrementally build up more complicated specs. Okay, so that's nice. There's also Mali integration, which is something I hacked up during one of the talks today, so it's still very, it's not on GitHub yet, but thought I should have that in there, and at least the validating part does actually work. We also have specs for Regal expressions themselves, which might be interesting if you're writing them and you want some validation on that, and so you can validate those, and since we have those, that also allows you to generate them, which is maybe less interesting for you, but it's interesting for us. Except that currently half of the time that blows up the stack, so that's something I still need to work on a little bit. But with those, that's going to help us to work on this next part, which is parsing. So turning a regular expression back into a Regal expression. And here I'm leaning on work that Gary Fredericks did in Test Chuck, which Tommy also mentioned this morning. Now, the parsing is, only sort of very partially experimentally there, but we'll get there. And again, once we have the generating and the parsing, sort of we can do generative testing on a full round trip of, this is really going to help us make this very solid. So let's look at what this looks like. So here's the original that I showed you in the beginning. This is the Regal expression. And okay, it's 10 times more code, but which one would you prefer to maintain? Then there's another case, and this is actually what inspired Regal in the first place. So I've been working for a while on a UI library for the terminal called Trickle. And so I need to deal with a lot of these ANSI escape codes to change like the colors in your terminal and all kinds of things. And so I wanted to have generative testing on these kind of things where you have an escape followed by 0 or more parameter bytes in a certain range, followed by 0 or more intermediate bytes in a certain range, followed by a final byte in a certain range. And so this now converts. So I was first like writing this with specs and then like manually adding generators. And then I was like, well, you know, how do I know that these generators match the reg, you know, like it's messy. Whereas now I can basically take that snippet of specification, convert it very straightforwardly to this, and I can generate ANSI commands and use those in my tests. So it's pre-alpha, but it's developed in the open. You can grab it on GitHub. It's cross-platform. You saw that, you know, you can now get rid of those reader conditionals. And contributions are very welcome. It's outlined in the README, how to contribute, what the rules are. We merge very quickly. Moritz, who's not here, already did some really nice contributions. Now, if you can't contribute to code or you also want to help us in another way, we have all these open source libraries now: Coucha, Gloggy, DeepDiff, ANSI, URI, Trickle, Edenline, Zipperfetch, Fetch, growing collection of Lambda Island libraries, and we want to develop those backed by an open collective. So this is something you can commit or donate money into, and then that allows us to pay people like, for instance, Felipe, to work on some of this stuff, but also it's just extremely validating and motivating. So even if you can just put €2 in there, you know, it's not a lot of money, but it actually really motivates us to put more time into this stuff. And thanks a lot to Gene Kim, Amar Mehta, Art Semyonov, Nate Jones, also Next Journal, all the people who've already contributed, you know, and hopefully we can have a few more people on this list this weekend. Thanks a lot.
Thank you.